Assalamualaikum dear students, I hope you all are fine. So today we will discuss use of common oxidizing reagent that are useful for reactions that involve elimination of hydrogen. And among these reactions, today we will be discussing the reagents that are used for causing the dehydrogenation of alcohols. So what do we mean by dehydrogenation? Dehydrogenation means removal of hydrogen. So if we remove hydrogens from alcohol, we get aldehydes and we get ketones, right? So today we will discuss how we can make aldehydes and ketones from alcohol by means of dehydrogenation reaction. So the key concepts which we will discuss here will be oxidation, dehydrogenation, and we will discuss about the oxidation of primary, secondary and tertiary alcohols by means of different inorganic and organic reagents. Right, so dehydrogenation reaction actually involves such reactions which cause elimination of hydrogen from a molecule. Right, so dehydrogenation involves the elimination of hydrogen from a molecule, right? So since that involves loss of hydrogen, so loss of hydrogen is one of the types of oxidation process, right? So oxidation reactions are defined as the process in which there is a loss of electron or loss of hydrogen or gain in oxygen. So since we are discussing the loss of hydrogen, therefore dehydrogenation reactions are actually the oxidation reactions. Right, so far we have discussed about the dehydrogenation reactions that resulted in aromatization. Also we have discussed about the dehydrogenation reactions that will yield the formation of carbon-carbon double bond. And today we will be discussing the dehydrogenation of alcohols to form aldehydes and ketones. Further, dehydrogenation reactions also involve the dehydrogenation of amines, also the oxidation of phenols and aromatic amines result in formation of quinones upon dehydrogenation. And also in future we will discuss about the dehydrogenation or oxidation of hydrazines, hydrozones and hydroxyl amines. So let's discuss about the dehydrogenation of alcohols. So why the dehydrogenation of alcohol is important? Because by this method we can form aldehydes and ketones. So here you can see that this is a primary alcohol. So primary alcohol upon oxidation results in formation of an aldehyde, right? And if we have a secondary alcohol, then we get a ketone from this process. So it's important reaction to remember that when you have to prepare an aldehyde, so you have to use the primary alcohol, and when you have a secondary alcohol, then we can form a ketone. So this oxygen in the bracket, that shows that this reaction is an oxidation reaction, right? So all of these oxidation reaction, if you can just see the reactant and the products, in the reactant we have two hydrogens. So one hydrogen is attached to the oxygen and two hydrogens are attached to carbon. However, if you see in the product, so we have lost the hydrogen that was attached to oxygen, and we have also lost the hydrogen that was attached to this carbon, right? So we have lost two hydrogen atoms from carbon and one from oxygen. Therefore this is type of oxidation reaction, and this is called dehydrogenation. So when we have to carry out the dehydrogenation reactions of alcohols on the industrial level, what we do is that we heat these alcohols in presence of copper oxide. Right, so heating these alcohols in presence of copper oxide will result in the formation of aldehyde and ketone. So depend upon if these R groups are hydrogen or carbon. So if one of these is hydrogen, we'll get an aldehyde, and if both of these R groups are carbons, then we get ketone. However, these industrial preparations cannot be used in laboratory because most of our alcohols which we normally used in the organic chemistry synthesis, most of these alcohols are temperature sensitive, and most of these alcohols cannot survive the temperature up to 300 degrees C, because in this process when you're using copper oxide or you're using zinc copper couple, then in that case this reaction, these simple alcohols can be converted into these simple ketones. But if you have complicated alcohols, if you have structurally complicated alcohols, then such alcohols cannot withstand such temperatures up to 300 degrees C. Right? So use of copper oxide or copper zinc couple, these are important for industrial use only, but they cannot be used on laboratory scale. So why industries are preferring these catalysts? Because these catalysts are very economical. So industries always prefer the reactions or the processes that are economical and result in formation of minimum number of products, right? So these reactants, these catalysts, since they're economical, so they are used in laboratory, but they are not normally used in organic chemistry labs. So when we have to carry out the dehydrogenation reactions of alcohols in the laboratory, we have two options. Either we can use oxidizing agents which are of inorganic nature, and we can use the oxidizing agents that are of organic nature. So let's first discuss the inorganic oxidizing agents which can be used for the oxidation of alcohols. Alright, so firstly we will discuss about the chromium 6 reagents which are normally used in the oxidation. Right, so chromium 6 is when used during the oxidation process, this chromium 6 is reduced to chromium 3. Right, so this is chromium 6 that's in higher oxidation state. Right, so as mentioned in the previous lecture, it's important that your reagent should be in higher oxidation state. So chromium 6 is the highest oxidation state of this chromium. So what happens that this chromium gains electrons from this alcohol, and this chromium is itself reduced and it oxidizes this alcohol. Right, so since chromium is oxidizing alcohol and is itself getting reduced, therefore that's an oxidizing agent. Right, so during the oxidation of alcohols, what happens that chromium 6 is reduced to chromium 3 and the alcohol is oxidized to aldehyde. So this reagent is important because it can also be used in the oxidation of aldehydes as well. Right, so normally what happens that when we have to carry out the oxidation with chromium 3 reagents, we take the solution of sodium or potassium dichromate. And because why we are taking the dichromate, because in these dichromates the chromium is in oxidation state of 6. Right, and we use sulfuric acid for acidification. Right, so since that's a salt and reaction of a salt with acid result in formation of an acid, another salt, so we want to convert this chromate into chromic acid. Right, so that's why we are making use of this acid which will act as a catalyst. So why chromium 6 is important in this reaction? Because if oxidation occurs, so there is a change in color. So if oxidation is not occurring, the chromium 6 has an orange color solution. Right, because of dichromate ions. But if the oxidation occurs and 6 is converted into 3, then solution which was previously orange will turn into green. Right, so if you have to make sure that reaction is occurring or not, if you have to see whether the reaction is occurring or not, just check the color of the solution. So if the solution is turning green, it means oxidation is taking place. However, if the solution is not turning green, it means oxidation is not taking place, and it's the dichromate ions which are giving this orange solution. So since it is very easier to determine the oxidation state of inorganic reagents, so this is the electron half equation for this reaction. So here you can see this chromium is actually in oxidation number 3. Right, so this chromium is gaining electrons. Right, so it's gaining 6 electrons. As a result, its oxidation state is being converted into oxidation state of 3+. So previously it was 6+, now it has become 3+. Right, so here chromium is reduced. So if chromium is reduced, definitely the other reagent, which is our alcohol, should be oxidized. Right, so different type of organic reagents, chromium reagents that involve chromium 6 in its oxidation state. These are potassium dichromate, or chromium trioxide, in both of these, whenever they are used along with sulfuric acid and water. So when you are using potassium dichromate as an oxidizing agent, you have to use sulfuric acid and water as well. And similarly, when you are using chromic oxide or chromium trioxide, then you have to use sulfuric acid and water. So these reagents oxidize alcohols to yield different products. So depend upon the nature of this alcohol, we get different products. So if we have primary alcohol, then in that case the oxidation will convert this primary alcohol into carboxylic acid. So since we are going for the preparation of aldehydes, so these chromium reagents are normally not useful for us. Right? So we are interested in formation of aldehydes, but this reagent results in formation of carboxylic acid. So this is not of use to us because we don't get the aldehyde. Instead, we get a carboxylic acid. However, the secondary alcohols upon oxidation result in formation of ketones, and if you have a tertiary alcohol, then no reaction is observed. Right? So why no reaction is observed? Because earlier we have seen that in order to cause the dehydrogenation reaction, there must be one hydrogen on carbon and one hydrogen on the oxygen. So in case of tertiary alcohols, there is no hydrogen on the carbon which is attached to the hydroxyl group. So dehydrogenation cannot take place, right? So because of absence of hydrogen on the carbon which is directly attached to the hydroxyl group, so oxidation of tertiary alcohol will not take place with these reagents. So suppose that we have to use chromium reagents, and as mentioned earlier that these chromium reagents are don't give good results with aldehyde. So what we do is that we make use of modified chromium reagents. Right? So these modified chromium reagents are weaker oxidizing agents. Therefore, what happens that when we use these modified chromium reagents, we get aldehydes from alcohols. So if you want to get aldehyde from primary alcohol, then you don't have to make use of simple chromium reagents. Instead, we use the chromium 6 reagents. So what are the chromium 6 reagents? These are pyridinium chlorochromate, and this pyridinium chlorochromate is abbreviated as PCC, right? Pyridinium chlorochromate. So why is that so? So pyridinium means this is pyridine, and EM indicates there is a positive charge on nitrogen, right? So whenever there is an EM in a name, always remember that it means there should be a positive charge on some electronegative atom. So there is a positive charge on nitrogen, which is indicated by EM, right? So this is pyridinium, and chloro means there is chloro and chromate, right? So 8, whenever it comes in some inorganic reagent, it means there is a negative charge on electronegative atom, right? So this is pyridinium chlorochromate. Similarly, we have pyridinium dichromate. So again, pyridinium, so it's a positive charge on the nitrogen, and we have dichromate here. So you have 2 negative charges, and in order to balance these 2 negative charges, must have 2 positive charges. So we have 2 pyridine molecules which are in the protonated form. So this is protonated pyridine, this is also protonated pyridine, and that's the dichromate. Right? This is the structure of pyridinium dichromate, and it's shortly abbreviated as PDC, pyridinium dichromate. Lastly, we have another molecule which is chromium trioxide pyridine, right? So this is chromium trioxide, right? And these are the pyridine. So just note that we have not added the EM with that. It means that pyridine is not positively charged here, right? So this is chromium trioxide, and these 2 pyridines are forming sort of coordinate covalent bond with that. So all of these 3 are modified chromium reagents. And what's the use? The use is that whenever we have a primary alcohol, we always get aldehyde from these alcohols. We don't get the carboxylic acid, which was the side product. So when we use these reagents, right? So dichloromethane is preferentially used as a solvent. So just for example, suppose we have an heptanol, so that's a primary alcohol, and we use any of these. For example, we have taken this PCC and we are using the dichromate dichloromethane as a solvent, so we get this heptanol, which is an aldehyde. So we don't get carboxylic acid from this one, right? So when you are using secondary alcohols, we get a ketone, right? So when another part of the molecule may be sensitive to more rigorous conditions of acidic or acidic conditions, then we make use of that complexes. So suppose if a compound is acid sensitive, it has some functional groups which react under acidic conditions, then we can make use of these reagents. So if you remember from the previous slides that whenever we are to use chromic oxide, we have to use sulfuric acid and water with that. Similarly with potassium dichromate, we also have to use the sulfuric acid and water with that. But suppose if your substrate, if your alcohol is acid sensitive, right, if the functional group present in a molecule that reacts under acidic conditions, so what happens that we get some undesired products. So under such conditions, we make use of these modified chromium reagents because these are suitable not only for converting the primary alcohols into aldehyde, but they are also suitable for the substrates which are sensitive to acidic conditions. Alright, so let's consider what is the mechanism when we use chromium 6, right? So whichever be the reagent, so we're just generalizing the mechanism, right? So mechanism with chromium 6 oxidation is very complex and involves many steps, right? So general reaction is that we get the chromium 6, and this chromium 6 is firstly reduced to chromium 4, and we get this ketone, right? So various intermediate steps are involved. For example, here we have mentioned that this alcohol is being converted into ketone and the 6 is being reduced to 4. Then this chromium 4 will further reduce to chromium 3, right? Because it can be further reduced, but chromium 3 will not reduce any further, right? So here again we have alcohol, and when we are using chromium 4, it's converted into chromium 3, and what happens, it has lost one electron, you can see here, right? But in chromium 6 to chromium 4 we have lost 2 electrons. So here we have caused the loss of 2 hydrogens, but since there is a loss of 1 electron, therefore we have lost 1 hydrogen, so here is a free radical, right? Similarly here we have lost 2 electrons, so this is chromium 5 and it's being converted in chromium 3, right? So since 2 electrons lost, so it means alcohols are converted into ketone. But when we say that's chromium 4 and it's converted into chromium 3, or when chromium 5 is being converted into chromium 4, then there is a loss of 1 electron, right? So whenever there is a loss of 1 electron, then always a free radical is formed. So similarly here you say that this is a free radical already, and chromium 4 is being converted into chromium 3, so again a loss of 1 electron. So 1 more electron will be lost and we'll get a double bond here, right? So always remember that whenever there's a loss of 1 electron, so we get a free radical, but whenever there's a loss of 2 electrons from the chromium side, then we get a double bond, right? So one thing that's important from this reaction, which should be clearly visible to you, that this oxidation with chromium 6 is a free radical condition. There is no formation of carbocation or carbanion, but we get the free radicals in this reaction, right? So overall reaction that involves a multiple series of steps, different steps, but basically what happens that this chromic acid, which we have used, suppose in case of potassium dichromate, when we react the potassium dichromate with sulfuric acid, we get chromic acid with potassium sulfate, right? So the salt reacts with acid to form another acid plus salt. So this chromic acid forms, so here you can see that chromium is in 6 oxidation state. Why? Because it's forming 6 bonds, right? So chromium is in 6 oxidation state. This chromium will react with this alcohol, right? So this alcohol will attack on this chromium here, so that will result in formation of a chromate ester. Again you can see that oxidation state of this chromate is positive 6. So next what happens, that this chromate will result in elimination of this group in the form of ketone. So just imagine that this electron So this bond is shifting here, right? So we are getting a carbon oxygen double bond, right? So, and what happens that we get a chromic oxide CrO3, right? So, and we get a ketone here, right? So this chromium that's in oxidation state of 4, right, it can be further oxidized. So it can lose one more electron. So when it will lose one electron, it will be converted into chromium 3. So chromium 3 cannot be further oxidized, right? So oxidation will take place until chromium returns to oxidation state of 3, right? So that's why we are using chromium with oxidation state of 6. So we now consider some examples, right? So we are carrying out the oxidation of primary alcohol, and we are using the sodium dichromate with sulfuric acid, right? So you may use potassium dichromate as well. So you say that this is a primary alcohol, and the primary alcohol under these conditions is converted into carboxylic acid. Since we are not interested in carboxylic acid, so whenever you have primary alcohols, never try sodium dichromate or potassium dichromate. Why? Because this oxidizing agent is too strong to just lead to formation of aldehyde. So once aldehyde is formed, it will further convert it into this carboxylic acid, right? So this reagent, which is potassium dichromate or sodium dichromate, that's not suitable for primary alcohols, but you may make use of the modified chromium reagent. If you have secondary alcohol, like that here you have secondary alcohol, right? So secondary alcohols, when they are treated with the sodium dichromate in presence of sulfuric acid, you get ketone. That's a reaction is very nice. And again, under these conditions, actually that's a chromic acid which is formed, and this chromic acid H2CrO4, actually that acts as the basic reagent. Now again we have a secondary alcohol. You can say how we are seeing that secondary alcohol, because this carbon to which this hydroxyl is attached, this carbon is further attached to carbons, right? So that's a secondary alcohol, and upon oxidation you have to lose one proton from this carbon and one proton from this oxygen, so we'll get a double bond here, right? Okay, so as mentioned earlier, the chromium 6 reagents are very powerful. So they are suitable for oxidizing secondary alcohols to ketones, because ketones cannot be further oxidized. However, if you are using primary alcohols, then we cannot get aldehydes, because as soon as the aldehyde is formed, it's further oxidized to carboxylic acids, right? So how we can get aldehydes from primary alcohol? We have two options, right? Either we don't use these chromium 6 reagents, we can make use of modified chromium reagents. Second way is that we can distill the aldehyde as soon as it is formed. How it's formed? Because the aldehydes are normally volatile, they have lower boiling points than alcohols. So when the aldehydes are formed, they boil fastly, so they can be distilled off immediately as soon as they are formed, right? So if you want to get the aldehyde from primary alcohol and you want to continue with chromium 6 reagents, then you can distill the aldehyde which is formed as an intermediate in this reaction. Otherwise, better option is always to go with modified chromium reagent. Now, so consider if we are having tertiary alcohol and we are trying to oxidize tertiary alcohol, right? So tertiary alcohols cannot be oxidized. Why? Because as I mentioned earlier, the carbon to which hydroxide is attached does not have any hydrogen, right? So oxidation is difficult. So when we try to carry out the oxidation of tertiary alcohols, what we get the breakage of carbon-carbon bond, right? So instead of formation of aldehyde or ketones, we just get the breakage of a carbon-carbon bond, which is not suitable. So here's the summary, that whenever you are using the oxidation with chromium 6 reagents, if you have a secondary alcohol then we get a product of ketone, whether you are using chromic acid or PCC. If you want to get aldehyde from primary alcohol, you have to try PCC or any modified chromium reagent. And if you have to get the carboxylic acid, you have to use chromic oxide with primary alcohol. So you cannot get carboxylic acid from carboxylic acid from secondary alcohol. And if you are using PCC, you can get aldehyde from the primary alcohol. So you should know about these. Okay, now we will try with some other variations of chromium reagents. First, we are using Jones reagent, right? So Jones reagent is actually chromium oxide. This is chromium trioxide, CrO3, and here we are using sulfuric acid as usual, but instead of water, we are using acetone, right? So whenever you are using chromium oxide, CrO3 in presence of sulfuric acid with acetone as a solvent, this reagent is called Jones reagent. Right, so Jones reagent is very oxidation is very rapid, reaction is very exothermic, yields are very higher, right? And the advantage is that it does not affect the double bonds or triple bonds, right? So it does not oxidize unsaturated bonds. The Jones reagent oxidizes primary alcohols to carboxylic acid and secondary alcohols to ketones. Again, this reaction is not suitable for converting primary alcohols to aldehydes. Right, so suppose we have a secondary alcohol, so you can get easily the ketones from the secondary alcohol, but if you are having a primary alcohol, then problem will remain the same. We will get carboxylic acid. So now we have chromium reagent, right? So Collins reagent. So Collins reagent again is a complex of chromium 6 oxide with pyridine and dichloromethane. Right, so the advantage of this reaction is that it is used to selectively oxidize primary alcohol to aldehyde. Right, so Collins reagent may be a choice, maybe reagent of choice if you are trying for aldehydes. Right, so primary alcohols will be converted into aldehydes. Also, many functional groups are stable with this reagent, so it doesn't react with other functional groups as well. Right, so it can be used as an alternate of Jones reagent and PCC, right? So however, this reagent also oxidizes secondary alcohol to this ketone, right? So the problem with this reagent is that it's very difficult and dangerous to prepare. Why it's dangerous to prepare? Because it's very hygroscopic, right? What's hygroscopic? It means it absorbs moisture very rapidly, and when it absorbs moisture, it inflames during the preparation, right? So you have to ensure that there is no water in the reaction mixture, or this reagent does not comes in contact with the water, because whenever it comes in contact with water, it catches fire, right? So this is very difficult and dangerous to prepare. Also, one of the major disadvantage of this reagent is that you have to use excess of this reagent to complete the process. So if you are taking 1 mole of reactant, you have to take 6 moles of this reagent. So it's very expensive, it's dangerous to prepare, also difficult to prepare. So that's why these are the disadvantages. So normally Collins reagent is not used in the oxidation of alcohols. Okay, now we have another option. Instead of using the chromium reagents, we can try for manganese oxide. Right, so there are a variety of other inorganic reagents, and manganese oxide is one of them, and it has the advantage that it selectively oxidizes only the allylic or benzylic alcohols. So you can say here, this alcohol, this is primary alcohol, but this is also allylic alcohol, right? How is allylic? Because there's a double bond, and this to this double bond there is a single bond carbon, and this sp3 carbon is an OH attached. So if an sp3 carbon is directly attached with a double bond, this sp3 carbon will be considered as allylic carbon, right? So this hydroxyl will be allylic group. This is allyl, right? So if you have an allyl hydroxyl group, or if you have a benzylic hydroxyl group, this is benzylic. So this is benzene, and this is benzylic carbon, the carbon that's directly attached to the benzene. So this benzylic carbon has a hydroxyl group attached to it, right? So whenever you have a benzylic alcohol or an allylic alcohol, both of these are shown in red, then with manganese oxide you will only oxidize this allylic alcohol, right? So the other alcohol, this is not allylic, right? Similarly, this alcohol is not benzylic, so these alcohols will remain unaffected. So manganese oxide is very useful, it's very effective, because it only oxidizes the allylic or benzylic alcohol. It will not touch any other alcohol, so this is the advantage. This is a selective reagent. Another reagent which can be used for oxidation of alcohols by use of sodium oxychloride. So sodium oxychloride is also called sodium hypochlorite, right? This is common bleach which is available in our homes, so it means it's very highly inexpensive and it's readily available. So what happens that if you have a secondary ketone, a secondary alcohol, the secondary alcohol is readily converted into ketones, right? So it's not useful for use with primary alcohols. So however, if you want to carry out the oxidation of secondary alcohols to ketones, you may try this reagent because it's very inexpensive and is readily available. Now we have PCC. So PCC stands for Pyridinium Chlorochromate, right? So this is the structure of Pyridinium Chlorochromate. So that's a complex of chromium trioxide with pyridine and HCl, right? So advantage is that this reagent can oxidize primary alcohols to aldehyde, and it can oxidize secondary alcohols to ketones as well. So we are discussing just some reagents that can be used to we are discussing some examples in which we use PCC for oxidation. So for example, we have a primary alcohol here. It's a primary alcohol and we are using PCC, and again the solvent should be dichloromethane, so we get an aldehyde. And similarly, if you have an heptanol, then one heptanol upon reaction with PCC in dichloromethane, that will yield the heptanol, which is the desired product, right? So okay, now we have these two structures, and this is a quiz for you. You have to predict what reagents should be used for oxidation of these alcohols. So we have a cyclopentanol, and you have to convert the cyclopentanol into pentanone. So you are converting this alcohol into this ketone. So you have to suggest which reagent should be suitable for these conversions. So just for hint, I'm just mentioning to you that you may make use of more than one reagent. So more than one reagent may also be useful for such conversions, right? So you may use that reagent, and that reagent as well. So you have to just suggest which reagents will be useful for such conversions. Similarly, you have 2-octanol, right? So this is 2-octanol. We have a double bond here and a hydroxyl here. So you have to suggest which reagent will be suitable for conversion of this alcohol into this aldehyde. Right, so I suppose that you will be able to answer these questions on the basis of today's lecture. Right, so just to summarize it in the end, we have seen about dehydrogenation. So dehydrogenation is a type of oxidation reaction, right? And what happens is that when we oxidize an alcohol, it results in loss of two hydrogens, one from carbon and one from hydrogen. So as a result of this elimination of hydrogens, we get a carbon-oxygen double bond. So we can convert alcohols into aldehyde or ketones by means of this dehydrogenation reaction. So we have seen different chromium reagents which can be used normally when you use potassium dichromate or sodium dichromate in presence of sulfuric acid. So these reagents are very strong reagent. And the problem is that when we use primary alcohol with these reagents, we get only carboxylic acid, However, we are trying for aldehyde, so these reagents are not suitable for reactions with primary alcohol. But in case if we are using secondary alcohol, we get the ketone, which is the desired. So these chromium reagents are stronger reagents that are suitable for oxidation of secondary alcohols. So in case we have to oxidize the primary alcohol, there are various reagents available. We may make use of the modified chromium reagent, which include PCC, PDC, right, and pyridinium chromate complex. Also, we can make use of the common bleach, which is sodium oxychloride. We can make use of the manganese dioxide as well. So each of these reagents has its own limitations. For example, Collins reagent, that's a selective reagent. So Collins reagent can oxidize primary alcohols to aldehyde, but its largest disadvantage is that it's very difficult to prepare. So it becomes difficult to prepare. The reason is that it is highly hygroscopic. It absorbs moisture, right? So as soon as it's formed, it's very, very difficult to ensure that there is no single drop of water in the reaction mixture, because as soon as it's formed and there is a single drop of water in the reaction mixture, it catches fire. So that's highly inflammable, right? So the Collins reagent, although that's useful, but it has its own limitations. Jones reagent is also not suitable from primary alcohols because it also oxidizes the primary alcohol to carboxylic acid, right? However, the reagents which we have studied so far, these reagents are almost all suitable for conversion of secondary alcohols to ketones. You can use any of the reagents for oxidation of secondary alcohols to ketones. So hope you have understood this lecture. Thanks for today.